Hello and welcome to another free code session. My name is Jason Bach and I am having a Belching Beaver. I'm not kidding. That is the name of this beer. Slightly bitter, just a little bit, but it's okay. You know, I did one of those things where you get like the 6-pack and you try different things, and it's all right. It's not knocking my socks off, but I've had worse, which just doesn't sound like a really ringing endorsement. Let's have another sip, why don't we? Yeah, it's okay. All right. So I spent some time this afternoon going through all this projected type stuff, and maybe it's because I'm getting tired, but I'm also getting tired of solving this problem, and I just want to get over the end. So this is going to be fixing some stuff I just wrote with tests, but I just want this to work. When I was writing tests for all the pointer stuff, and delegate pointers are weird because they're pointers, they're function pointers, but they're not like weird pointers with where you allocate on the stack. It's kind of a little odd, but in any event, yeah, you're really restricted, especially with pointers. Like, you can create a method that returns a pointer to an int, but good luck trying to make that work, because as soon as you leave, your stack's gone and what you're pointing at is no longer there. And it's like, well, that sucks. So, it became like these tests where I had to keep it in there, but there really wasn't much to test. And now I'm doing these ref-like types, and I said, long discussion in my head where I finally just said, I'm taking out all this factory method stuff. If you want, in fact, the only way to call these builders is to call the constructor, the vast majority of code out there. That's the thing I finally realized, is the vast majority of code out there is going to use arg.is. I don't know if you can hear my little kitty. Hold on. I'm going to see if he's around. Hold on. All right. He's in here. We'll see what he does. I don't know where. Oh, he's going back to the door. I don't think he was meowing, but now he wants to go back out. Sully. Hey. Nope. He's done. Wait. All right, whatever. He was crying out in the hallway, so I let him in, and then he decided, nope. Didn't hop up on my table or anything. So, very nice cat. I like our new little kitten, but he's just being a little bit of a whiner. Anyway, so I said, the vast majority of code is going to use arg.is, arg.any. And for the cases where you use pointers or ref-like, struct types or whatever, fine. Use the constructors. You can use the new syntax. And what I really realize is for pointers, the only thing you can say is, I don't have any validation. I don't care. So there's going to be none. It's always going to be true. I just care that you called me. It's basically saying arg.any. This is the same as, I could put comments here. I could put like triple comments here, because then maybe they would just show up in the IntelliSense. God, why do I talk like that? Because now I want to do that. This is just to say it's going to be this value. Okay. And that's it. There will be implicit conversion if you do it for a pointer type, but then that's it. The only thing is going to be value or evaluation, that, and then ref-like is going to be just one thing, because the only thing you can do is validate it. And I'm almost positive you can't pass in a span of to this and keep it around. I'm almost positive of that. So the only thing you're going to be able to do is do a validation, and then as valid just does the validation. That's it. So what's going to break now, though, is some code I wrote for pointers, because the syntax isn't there, but that's okay. We should be able to fix that with all speed. Yep. Because these no longer have is. So we just say new. And then that goes away. Same thing here. Oh, that's interesting. P-value. Wow. Whoa. No. That's argument for int pointer value. What? No, that's wrong. Implicit operator arg. Yeah. So how did that even think that that was going to be a, we come back up here. It should have taken off all of the things. That's a delegate. This is the int pointer. In value. We should have, yeah, because it doesn't generate for this one. It does here. It's public static implicit operator that to that. So that should work. It did before. Int rocks argent. Yeah, that is weird. That is really, really weird. Because that's an argument for int pointer. And then down here, yeah, we no longer have this. So we just say new. And then that works. And these never had the implicit conversion, so we just say new again. And you could say new argument for delegate int pointer, just say new here, and that will work as what you're expecting as an argument. But this is kind of strange. Why would it do this? The conversion should still work. Yeah. Okay, so maybe it just got confused. Let's not run all tests. Let's just run these. Okay. Okay. All right, we're going to do one more set of tests because honestly, I don't know if you can tell, but I'm already like not passed out, burned out on this feature. Come on, I said that. I want a new file. Ref struct. What do I call those? Pointer tests? Yeah, we'll call these ref struct tests. Okay. And frankly, it's not that I don't care, but it's kind of like I don't care. Sort of like I don't care. Public interface. I have span. I can't even type. So we're going to say we have void foo of a span of int values. Okay? And you need to have system there. Okay? And then we're just going to have a test here that says framework. And then we say public static void. And then what are we doing here? What are we doing here? What is our purpose in life? Why are we here? Oh, I meant to suffer. Create. We're just going to do a create, because I got a thing, and that's all I care about. Rock is equal to rock dot create. I have span. All right. Does it build? Because it should have generated the code, and if it doesn't build, then we already know. Yeah, a whole bunch of crap went wrong. Rock.methods. So we're going to dive into that. And we're going to look at these errors. 12. What's 12? Oh. Yeah. I think I done goofed. How did I done goof? It's because for the span of t, that if it's closed, it should say arg evaluation for span of int, and it just span int. This should just say span of int. Same here. Arg evaluation for span of int. This still needs to have the type here. Okay, but and then is valid needs to have if it's an open. So we're going to be spending the rest of this episode and probably 2 more trying to figure out if a generic is open or not. Because if it's closed, then all the types just become 4. If it's open, then the delegate name has to be this. Actually, then, yeah, the the delegate name has to have the T in there, and then the class name has to have the T in there, because then there'll be span of T, and it comes from the class name, not the, yeah. Crap. This is okay. I was not completely unsurprised that this failed as badly as it did. We should have a void bar of T, span of T values as well, because we want to have both of them generated and see how that works. We could also have the T up here, but that's the type that, never mind. It's like I'm so close, and I'm fearing that this is going to go down a humongous rabbit hole. Extensions, I-type symbol exception. We are going to make a internal static bool is open generic. This dot I type symbol self. If self is I named type symbol named type. Otherwise, we just say return false. Because if it isn't, then we can't have any generics to look at. Then we say for each, for var I is equal to 0, I less than named type parameters, length I plus plus. And then we say if named type arguments of I does not equal named type parameters of I, we say return true. Okay? Because that means that you have an argument that has been set. But there's a catch here, I just realized. We need, like, if you had something of 3 and then all 3 have been set, you have to have all 3 of them to be closed. So that's not quite correct. Var closed count is equal to 0. Okay? So we're going to say closed count plus plus. And then we come here and we say if closed count is equal to named type parameters length, now we return true. In fact, we can say here return closed count is equal to that. There. Okay, so that should be correct. Now the thing is I got to actually write a test for this. I was watching today. I bring him up occasionally, but I was watching Jonathan Blow do a live stream today, and it was all this TDD, and it sucks, and you're writing 5 times as much code as what you usually do, and now you got to maintain that, and blah, blah, blah. And, you know, I will say this. I've gotten to the point where the whole demarcation of end-to-end tests, system tests, integration tests, unit tests, but I'm just test your code. Make sure that your code is doing what you think it should be doing. That's really what you want to do with tests. And, well, that's one of the things you want to do with tests. You also want to make sure that if you change something that you have a hope in hell that you catch it by having your test either pass or maybe a test now fails and you're like, wow, I did not expect that. And you can go dive in and figure out hopefully why rather quickly. So I'm like, the TDD thing, I personally don't find a lot of value in. I did it when I first started, but I don't ever, as you probably have seen throughout all my videos, if you're one of the poor saps that's actually watched all 200 plus videos that I've done, that's not how I write tests. I don't write them before I actually write the code. That's a very odd flow to me these days. Rather, what I will do is, what you're seeing now is like, well, I need to eventually write tests for this and I'll eventually get to it and blah, blah, blah. But I don't write them before I need to. I find that not to be a good flow. And I'm not saying that's wrong. I'm just saying it's a technique that if you don't find the technique to be helpful, then don't do it. Right? Exactly. You're right, Jason. Okay, so what I want to do here is open generic. Okay. And what would be nice is if I had a type symbol for parameter. If I had a public class target of T1, T2, T3, okay. Let's do this. Let's do this. Public class A. Doesn't matter. Whatever the name of the class is, doesn't matter. T1, T2, T3. Okay. And now we're going to have a public class target where what's coming in here is going to be int of A. And we don't care about this. We're going to say this is false. Okay, that's our first test. So let's get rid of these. Let's get rid of this because we don't need that. Don't need this. Where are we grabbing this from? Get type symbol from parameter. So that's the only thing we're going to need in this case. So we can get rid of that. And now we're just going to say get type symbol from our only, we're going to have one method declaration and there's only going to be one parameter. And so, yeah, that should do exactly what we want. So we can say this. So in this case, what we want to say assert that is open generic is equal to bool expected value. We do that, we do that. And please let me run the test. The beer's not too bad. Oh, it failed. It was true. It's open. How in the heck could it be open? Well, Jason, you see, this is why you write tests. Because it should be false. Let's run this and see what happens. I've been thinking also about performance, and I know I'm probably doing things nowhere near as performant as I should be, but the type symbol should be an int. Okay, let's say F5. This, oh, it is a name symbol. Well, yeah, because it's going to have no type parameters, but just because it has no type parameters, we need to say extra check. This is why you write tests, because when you're a dummy, it's greater than 0 and close count is equal to that. There we go. Now run this. All right, now we're going to do this. We're going to have a case where we have public class of A, but we're going to have a foo of T1 and T3, where this is a of T1 int T3. Okay. Is this an open? This should be, and it is. And we're going to do the case where this is just a string int. Doesn't matter. This should be false because it should not be open. It's a closed generic. Ah, fart. Yeah, well, can't win them all, can you? It is failing on the one that, yeah, it is. Okay, so obviously I am an idiot. Take the breakpoint off of here. And type arguments is 0. Type parameters is T1. So it increases, and increases. Now here, 3, 3. Oh, crap. Wait a minute. I think I need to rethink my things. If they're equal, then, oh, I thought of this wrong. I was doing this wrong. If they're equal, then that means T1 is equal to T1. You automatically have an open type and you can just bail. You don't need to do this. Okay. Sometimes on a Sunday afternoon when you're drinking a beer and just relaxing and chilling, you don't necessarily think all your things through. God. Or you're an idiot. Which one is actually not working now? Still that one. Okay, well, equal, not equal, if they are equal. I think. Nope. Well, now that one's true, and it should be, now it's saying it's false. Okay, I need like a combination of the two ideas. If you're an open generic, oh. Well, yeah, that's kind of weird because that is open. So your type arguments, the first one is a T1. This is also a T1. Okay. So it should return as true, and it doesn't. It's a type symbol. Let's do this. Equals named type parameters of I. Symbol quality comparator. Default. They're not equal. This is not the first rodeo. Yeah, I don't understand. Type. They're both a T1. If the names don't equal, that doesn't make any sense. But because unless you had a type of T, well, then it would get confused, I think, because it'd be like, well, you're saying the generic is a T1, but you have a type of T1 in scope, and I can't tell what you're doing. So in the interest of brevity, name. It doesn't feel quite right, but it works. Okay, I did all that to do another episode. But again, the reason why I'm doing this is because when I get to my not this, but up here, all the way up here, is to do ref like archetype. Is actually, you know what I want to grab before I forget. Let's just put this back into play, okay? Because what I want to do is, why did it do 2? Oh, I know why it did 2. Well, it's funny because the reason it did 2, because the bar does have a T, this one doesn't. And so that's interesting that it did not do an evaluation. Arg evaluation for span T. It must have thought there was 1. But in this case, oh, sorry. There it is. It was hiding because I don't have my spacing. Yeah, this is for this, and then there's one created for that. This one's actually correct. So when it is a generic, it's doing the right thing. It's when it's closed that I needed to actually say like arg for span of int, or however I'm doing it. Use the flatten name. The same thing for, like, this is fine and this is fine. Those are fine. This one though, that name. Okay, but I will do this in the next episode. So thank you all for watching. Leave comments and questions below. See you in the next episode.